Hello everyone, today we're going to be talking about perimeter and circumference. Alright, there's a lot of this where it's just ideas for you to think about. Alright, those questions I'm going to kind of point those out to you. I'm not going to go ahead and answer them myself, so I'm just going to point out where you might want to stop, think for a little bit about what you think it is. Alright, so we're talking about perimeter and circumference. Alright, the rest of the year we're going to start thinking about dimensions. Alright, and how do we measure various things. So how do we measure the distance around something, how do we measurize the space inside of something, how do we measure the space that covers something. Alright, so up here we have questions on is what do we measure in one dimension versus two dimensions. Alright, that's something good to think about. All right, what we're talking about today with perimeter and circumference, right, both of those go here. All right, we're not going to worry about two dimensions today. However, you might want to go look or think about what that concept might be. All right, now, first we have perimeter. All right, perimeter is just the distance around the edge of a closed figured shape, or the distance around a polygon. All right, all we're going to do is we're going to add all the sides together. All right, for this square, that side's s, well, that would be s plus s plus s plus s, or 4 times s. For a rectangle, it's width plus width, or 2w, plus length times length, or 2l. All right, for a triangle, let's just add all three sides, b plus c plus d. For the pentagon, since it's regular, remember regular means that all the sides and angles are congruent. If that's S, there's 5 sides, so 5 times S. Right? If it's simple shapes like that, it's pretty easy. All right? Notice, here's another spot for you. Describe perimeter in your own words. So take some time. Think about if you were to describe perimeter to someone, how would you explain it? Perimeter is whatever you want to say. All right. Down here we find some examples. All right. This first one over here, we know this side's 11, 8. All right. Oh, I'm sorry there. 8 and 2. That's what they give us in this problem. All right. This bottom side right here, all right, let me highlight that. All right, they're saying is 8 minus 2, because they're taking this whole side, which is 8, and subtracting this part right here, which is 2. We know that because of the mark, so this side is 6. They're playing the same game right here, doing 11 minus 2, because the whole thing's 11, minus the 2 right here leaves us with 9. All right, so my perimeter is just 11 plus 8 plus 2 plus 2 plus 9 plus 6, which equals 38. All right, they just took this plus that plus that plus that plus that plus that. Altogether, that equals 38. All right, the second problem down here is a trapezoid, so it's a little bit trickier. We need to find this side. All right, we need to find what is x. All right, well, since there's a right angle right here, and these sides are parallel, since it's a trapezoid, we can slide that over here, and we know that that's a right angle. All right, we know this much is 10, which means this part to the corner is 8, because 10 plus 8 is 18. And we know the height is 6. Right? It's a right triangle, so we can use Pythagorean theorem. 6 is one leg, plus 8 squared the other leg, equals the hypotenuse. That gives me 100 equals x squared, or x equals 10. So this x is 10. And then for perimeter, I just add all the sides, so 18 plus 10 plus 10 plus 6, which equals 44. All right, same idea here on the third one. We need to find x. All right, this side's my hypotenuse, so that's my c. I'm going to let 9 be a and x be b. So I'm going to do 9 squared plus x squared equals 41 squared. All right, we'll find x from there. Perimeter, we add all three sides. All right, hopefully that's pretty simple. All right, that's perimeter. Now, a couple small things about circles before we go into circumference. All right, we need to know what diameter means, and we need to know what radius means. Actually, I'm going to do radius in a separate color. We need to know diameter, and we need to know radius. All right, diameter is any line that goes from one side of the circle to the other side of the circle through the middle. All right, the radius is a line segment of the circle that goes from the center to the outside. All right, you could also draw it from O to C, but I don't want to cover up the other one. All right, so just notice I could also put a line for going from O to C the other way there too. All right, the reason we need those is because the perimeter of a circle, or its circumference, all right, depends on our diameter or our radius. All right, notice once again here, we have described circumference in our own words, similarities between perimeter and circumference, and different between perimeter and circumference. Take some time, think about those. All right, if you need to, pause the video for a second, but I'm going to keep going. All right, the other thing that we have to worry about when we're talking about circumference is pi. All right, and we'll talk a little bit more about that in a second. All right, now, the reason why diameter and circumference are related is if we take the diameter of a circle, all right, it takes just over 1, 2, 3 diameters to fill that whole outside of the circle. All right, so if we cut the circle and made it a straight line, it takes just over 3 diameters to fill it. All right, it actually takes, this little extra part is 0.14, with a lot more coming after that. All right, that number is how we get pi. All right, pi, which is 3.14159.265. All right, your calculator would generally round this next one to 4, but it's really a 3 because it's rounded up. All right, now what we generally do for that is we just say pi is about 3.14. All right, and if we have to multiply it out, that's the number I encourage you to use. Pi is 3.14. All right, hopefully something you've all heard before. All right, so what that tells us is since it goes around 3.14 times, the circumference, or C, equals pi times the diameter. All right, this next piece, that 2 pi r right there, happens because the radius is half the diameter, or the diameter is equal to 2 radii, the plural of radius. All right, so 2r is the same as d, so pi times d is the same as 2 times pi times r. All right, both of those will give you your circumference. The one you want to use depends on, do we know the radius? Do we know the diameter? All right, couple of examples of these so far. All right, this first one, we want to find the radius. All right, so we know circumference equals 2 times pi times r. All right, the circumference is 9 pi. So 9 pi equals 2 times pi times r. So we can get rid of the pi's because it's the same on both sides. And then 9 divided by 2 is r. That is 4.5. All right. Second one, they just want the diameter. All right. And they give us radius. So the radius equals 1/2 the diameter. Right? Or 16 equals 1/2 times d. Multiply both sides by 2. 32 equals the diameter. Notice underneath right here, all right, they said diameter equals 2r. They did 2 times 16. Doesn't matter which equation you use. All right. Third one, it wants circumference, and it gives us radius. So we're going to use pi, or 2 times pi times the radius. Sorry, I was thinking something else there for a second. So 2 times pi times 3. 2 times 3 is 6 pi. All right. This little e there means that they don't want you to round pi. All right. They want you to leave it in terms of pi. So we're just going to leave our answer as 6 times pi. All right. If we were to multiply that out and they wanted an exact answer, all right, we would just take 6 times 3.14 and we would get 18.84. All right. Now, since we rounded pi to 3.14, that answer is not exact. All right, so that would be a rounded answer. All right, so we're just going to leave this one as 6 pi. Notice, all right, all these units are centimeters. All right, we're not multiplying by any other dimensions. All right, we're just taking the number of centimeters around a circle 3.14 times, so our answer is still normal centimeters. All right, this last one's kind of tricky. All right, they want the diameter. Then they just say c equals pi. Well, if we want diameter, we know c equals pi times diameter. Circumference is pi. So pi equals pi times diameter. We'll divide by pi. All right, those canceled, so it's 1 on that side equals d. Notice it's 1 because we're dividing, not subtracting. All right, so the diameter is 1 centimeter. All right. Now, hopefully, there's a moment. What are the two formulas I could use for the circumference of the circle? So we have circumference equals something, or circumference equals something. I'm going to let you guys figure out what those are. All right, hopefully you can look above or back to the other page and figure it out. One uses diameter. One uses the radius. All right, then there's 4 problems here for you to try. All right, that's the second thing. That's it for circumference. All right, next we're moving on to arc length. All right, arc length happens when we don't have a full circle. So we're looking at part. All right, the first one they look at here is a semicircle, or 1/2 a circle. All right. Here they have a 1/4 of a circle. All right. And these other ones are slightly different. All right. Notice each time what they're doing, though, is they're taking the entire circumference each time, and they're multiplying it by a fraction. All right. Common things about each one of these fractions. All right. The bottom of the fraction, or the denominator, is always 360. All right. The reason for that is that each circle, if we go all the way around, is a 360 degrees. All right. The whole circle itself is 360 degrees. All right. So to find how much of a circle each part is, we have to look at this central angle, or this angle that we're looking at. All right? I know 180 degrees is half of the circle because 180 divided by 360 is 1/2. I know 90 degrees is 1/4 the circle because 90 over 360 is 1/4. The next one, 225 degrees. Well, I don't know what that is off the top of my head, so I'm going to put that over 360. Turns out I can reduce that to 5/8. All right? Other thing to notice here, all right? This one they gave us diameter. So we used pi times d for the circumference. This one, they gave us a radius. So we used 2 times pi times the radius for our circumference. Radius again, 2 times pi times the radius. All right, this one over here, they gave us the radius. All right, so when we plugged in for c here, we would use 2 times pi times r. If they gave us the diameter, we could plug in there pi times d. All right, that's our third equation. As we notice on the next page, here it is. All right, so far we've talked about 3 main equations. We've done perimeter, where we add all the sides together, circumference, where we either take 2 times pi times the radius or pi times the diameter, and we've talked about arc length, where we take the entire circumference of the circle and multiply that by the fraction of the circle we are looking at. So whatever angle we're looking at divided by 360. All right, as we scroll down here, this one, central angle is 270, radius is 16, central angle 45, radius 12, radius 4, central angle 315. We just plug those in. They give us the radius on each one, so we want to make sure we're using that formula, all right? The central angle over 360 times 2 times pi times the radius, all right? They gave you these answers exact down there, so you could just leave them in terms of pi. If you multiply it by 3.14, all right, just check the numbers down there, multiply by 3.14. All right. The last step we're going to on this is, what if we have a composite figure? All right, and what we mean by that is we have a straight edge and an arc. All right, so we have something that bends or curves, and we have something that's straight. Well, all we're going to do, all right, we're going to find how far it arcs, and we're going to add that to the straight part. All right, so notice they find their arc length first. All right, there's their equation. The central angle was 135 degrees divided by 360 times 2 times pi times 15, because 15 is the radius. And they get the number 11.25 times pi. All right? Now, since they have it multiplied by 5, this 30 part is 15 plus 15, the 2 flat parts, or straight parts. All right? Since there's no pi on the straight parts, they don't combine it with 11.25 pi. They just leave them separate. All right? The only time you would be able to combine those if we took 11.25 times 3.14. Sorry, guys, I typed something wrong on my calculator. Which is about 35.325. So I'm going to say 33. Plus 30, about 65.33 miles. All right, that's the approximation for what the perimeter is. All right, now, exact is perfectly fine. That's a perfectly fine answer. All right, that's what your homework quiz is going to be looking for, I think. Except for it'll say pi, pi, instead of the symbol. These mean the same thing, if we didn't write that earlier. All right? But in real life, that might be the number that makes a little bit more sense. 65 point and a third miles. All right? Notice they did the same thing here. We only have one straight side, which was the 8. And then our arc, well, there's no angle there, but it's a semicircle because it's a straight line across and there's no bend there in the middle. So that's 180 over 360, or you could just write 1/2. All right? They gave us 8, which is the diameter, so we just have pi times d, which is 4 pi. So their answer is 8 plus 4 pi, and is measured in centimeters. All right? Down here, there's 3 to try. All right? This one, kind of Pac-Man. Find the distance around Pac-Man. So we have this arc. All right? And we got those 2 straight edges. This, for this next one, it's kind of a rainbow. We have those 2 straight edges, and we got the inside arc and the outside arc. All right. Notice for the outside arc, you got to add all these together for your diameter. For the inside arc, they gave it to you. All right. This one, the angle on the outside is 90 degrees. All right. So they cut that 90 degrees out of the circle. So that means my angle would be 360 minus 90. And that's my central angle. All right. I'll let you finish the math there. All right. Big key on this last one. All right. We got our 3 straight parts. We have our 1 curved part, or our 1 arc. All right. Make sure you notice there's a tick mark there, tick marks there, tick marks there. So all 3 of those are 4 centimeters long. All right. That's it for the notes for today. The perimeter and circumference assignment and homework quiz is the last assignment for this week. So I hope you guys are all doing well. If you have any questions for me, please reach out. All right. Stay safe, guys. I miss y'all.